We have a similar problem in example 2, except that in this case our objective is to minimize our objective function f of xy equals x squared plus y squared. So even though we're looking to minimize, our approach is the same. If we come up with just a single point, we'll know that's a minimum. If we end up with multiple points, then we'll have to evaluate the function at multiple values to determine which is the max and which is the min. So we're going to minimize our function subject to this given constraint, which again we'll set equal to 0 by subtracting the 100 over. And the left-hand side of that expression is again our function g of xy. So we form our new function, capital F, which will be equal to the objective function plus lambda times the constraint function. And then we'll distribute lambda through to get a simplified expression here. So x squared plus y squared minus 6 lambda x minus 8 lambda y minus 100 lambda. So then we move on to finding each of those first partial derivatives, which in this case will be 2x minus 6 lambda. So we'll set that equal to 0. Then our first partial derivative with respect to y will give us 2y minus 8 lambda set equal to 0. And the derivative with respect to lambda will give us negative 6x minus 8y minus 100, and we'll set that derivative equal to 0. So we again have a system to solve. We can start off by taking our first two derivatives and solving for x and y. So in this case we would get 2x equals 6 lambda, or x equals 3 lambda. Looking at the second equation, we'll get 2y equals 8 lambda, or y equals 4 lambda. And now we have two results that we can substitute into our derivative with respect to lambda. So this will become negative 6 times 3 lambda minus 8 times 4 lambda minus 100, still equal to 0. So this gives us negative 18 lambda minus 32 lambda minus 100. Combining our like terms, we get negative 50 lambda, and then adding the 100 to the other side, we get equals 100. So in this case, we get lambda equals negative 2. So we can take that value for lambda, substitute back into our expressions for x and y. So 3 times lambda will be 3 times negative 2, or negative 6. 4 times lambda will be 4 times negative 2, or negative 8. So again, in this case, we only have one point to consider, only one value for x and y. So we know that that's our minimum, which is going to occur at the point f of negative 6, comma negative 8. And to get that minimized function value, we would take negative 6 and negative 8, plug those into the original function to get that minimized function value of 100.